And this is not part of the lecture, but it's really great to have you. And I remember correctly, a couple of years ago, you got the Heinz Zemanek Award from the Austrian Computer Society
Yes, true.
for your PhD. In fact, last Monday, our first speaker also got the Heinz Zemanek Award. So apparently there is a pattern.
Yeah, let's see if this pattern continues.
Okay, it's 5 p.m. It's my great pleasure to introduce Andreas Uhl. I already started in fact beforehand as speaker of today in our lecture series on sustainability in computer science. And not only that, Andreas got his for his PhD the dissertation prize of the Austrian Computer Society back then when he did his PhD. But I remember a couple of years ago within the Austrian Computer Society listening about fingerprinting and about digital forensics. So it's really with his mathematical foundations and mathematical works very much in this working in this area, and fingerprinting and footprint perhaps something similar. So I'm really very much looking forward to his presentation today. Carbon footprint of social media and other popular platforms. Andreas, it's your floor, and we are looking forward to your presentation.
Thank you, Getty, very much for this nice introduction. So I just switch off my video because, as we shall hear in my talk, this reduces the carbon footprint if we switch off the video, if it's not needed. So I will do so. Just keep it for a second so that you see who is talking to you. So to feed your imagination on that. Okay. Yeah, so the title of this talk is Carbon Footprint of Social Media. And I was just thinking about, okay, which topic would I choose for this presentation, and it turned out, okay, this is really an interesting topic here for me because I work with multimedia. So that's something I looked into, and I found it quite interesting to see what is going on in this field. So we will look at this topic, and to start with. So what is this term footprints? So what does this mean? And footprints are typically used to determine the impact of things we do as a human society. So by consuming products, by doing things like having video conferences and things like that, and try to assess the impact of this on the resources of the earth. And interestingly, there are different types of footprints seen in literature. So the first most well-known one is carbon footprint. It's also called greenhouse gas footprint in some contexts. And if you look into literature, most works deal with actual this carbon footprint. Yeah. And only a minority of papers in this field consider other types of footprints, like water footprint, land footprint, and material footprint. And I will start the discussion here talking about these different types of footprints, or what they mean, and how we can determine those. Okay, so starting with the carbon footprint, this of course serves as an indicator to measure, to determine the total amount of greenhouse gases emitted from some either activity or a product or a company or a country. And the important thing here is that we want to look at the total amount, and as we shall see, this is not so easy to determine what does this really mean, and how to assess that. So what's the unit that we report? So carbon footprints are typically reported in tons of emissions, CO2 equivalent emissions per unit of comparison. So eventual per year or emissions per person, per kilogram protein or per kilometer traveled and things like that. And we always write this like CO2e, so meaning CO2 equivalent. And very important, so for a company or a country that might be clear, but for a product, when we want to determine the carbon footprint, this includes the emissions for the entire life cycle, from the production along the supply chain to consumption and disposal. Okay, so and that's a problem. Yeah, if we want to determine the carbon footprint of social media, that means we have to look at the entire life cycle of all the products that are involved to enable social media consumption. And I would like to state this right from the start. This is really difficult. And this is a difficult task, and the difficulty is also an explanation for some phenomena that we see also in literature. And of course, if we talk about climate change mitigation strategies, this carbon footprint helps to discriminate those activities which have a high footprint, which have a high ecological cost from those with a low footprint. So it's of course beneficial to look into that. And in particular, if you think about social media, it's important to learn, okay, which activities do have a large carbon footprint and which do not. When we look at the definition, it talks about CO2 equivalent. So some scientists only really talk about CO2, but more commonly other important greenhouse gases are included. And in order to make this comparable, then there is the strategy that for those different greenhouse gases, we use carbon dioxide equivalents over some relevant time scale, like 100 years. So basically, we convert other greenhouse gases in CO2 to make it less complicated. And the terms greenhouse gas footprint or climate footprint are sometimes used alternatively to carbon footprint because it's not only about the CO2. We typically include also other greenhouse gases. Okay, carbon footprint examples, and yeah, it was already said. I'm working in fingerprints and handprints and also in footprints, so it's natural to show this nice example here. So this is a visualization of a footprint and shows some components of such a footprint that need to be considered. And I just wanted to give some examples about annual CO2 emissions, meaning ton per persons in the year 2021 of different countries. And we see large differences here. So this is done alphabetically. So we see Australia with 15.1 tons per person CO2 emissions, Austria 7.2, half of this basically, then Canada again 14.3, China 8.0, France 4.7, and so on. What is interesting, for example, India with 1.9, so rather low compared to other countries. Kuwait 25.0, so really huge carbon footprint. On the other hand, Tanzania 0.2 and the US 14.9. Yeah. So there are large differences. And of course, if we look at those, why does Kuwait has such a huge carbon footprint? Well, all the electricity is gained by burning oil, basically. And this makes this large footprint here. On the other hand, and we will see several examples of this concerning France. France has a rather low one, and here the problem is that when looking at the carbon footprint only, we regard the atomic plants of France as being very well for the environment. So concerning carbon footprint, that's true. But concerning other footprints, that's no longer true, of course. So there is already a bias to be seen here. So depending on which footprint we look at, so we have very different results. And of course, countries with a where the economy is rather weak and industrial production is weak. We have an example like Tanzania here with 0.2, the carbon footprint is low. Okay, for measuring the carbon footprint, there is a protocol in existence. So the greenhouse gas protocol is a group of standards that are most commonly used for greenhouse gas accounting. And so these standards have been published by the ISO under the number 14064. This is an entire standard suite, and this is for greenhouse gas accounting and verification. It was released in 2006. And the standard divides emissions into 3 scopes. And the scope 1 covers all direct greenhouse gas emissions within a corporate boundary. So this is typically done for companies following this standard or by a country. But here we talk about a company. So this is the direct emissions and includes direct fuel combustion, the vehicles of the companies with their combustion, and several other fugitive emissions here. Scope 2 covers indirect greenhouse gas emissions, where we consume purchased electricity, for example, heat, cooling, or steam. So these are generated at a different site, but nevertheless, this is consumed by this company, for example. And then we have the scope 3 emissions, where this includes emissions from suppliers and product users, also known as participating in the value chain. Also, the transportation of goods and other indirect emissions are part of this scope. Here's a visualization of that. So here we have the direct scope 1 emissions, which are the obvious ones, right? So when producing goods, for example, or using company vehicles for transporting stuff, we have these direct emissions. And we have the scope 2. This is when using electricity or steam or whatever from other sources, and the scope 3 emissions from these indirect emissions, like waste management, for example, business trips and so on. So you already see here when talking about emissions, we have to think very comprehensively where emissions can occur when producing goods, for example. So looking at those 3 levels, it gets clear that this is kind of not so easy. Okay, we do not only have the carbon footprint, we have also water footprints. And water footprint is an indicator that measures the volume of fresh water needed to produce some goods and services. And again, we have different types here. So for example, we have the blue water footprint. This is what we classically would think of. So this is the volume of water that has been sourced from surface or groundwater resources and is either evaporated or incorporated into a product or used when producing this product, or also taken from one body of water and returned to another. And the green water footprint is basically important for agriculture and forestry. So this is a water footprint which deals with water from precipitation. So the water that has come down by rain is stored in the root zone of the soil. And this is either lost by evaporation and transpiration or incorporated by plants. So this is, of course, interest here is very concentrated in agriculture. And then we have the gray water footprint, refers to the volume of water which is required to dilute pollutants, like industrial discharges, untreated wastewater, to such an extent that the quality of the water is okay again. So we have these 3 different types of water footprints. We have 2 additional footprints, like the land and material footprints. Land footprint is the real amount of land, wherever it is in the world, that is needed to produce some product or used by some individual organization or by nation. To give an example here, the land footprint of the European Union was estimated to 269 million of hectares, which is 43% more than the agricultural land available in the European Union. So we import a lot of agricultural goods. And for this, we use land not in the EU. Yeah, and by the way, 73% of this land footprint was due to the consumption of animal products, and the rest to vegetable oils and plant-based products. And finally, the material footprint is a consumption-based indicator of resource use, and yeah, provides the link between the start of a production chain, where we extract raw materials from the soil, for example, and its end where the product and the service is consumed. Okay, then I already mentioned that this term life cycle analysis or assessment is a method to evaluate the environmental impact of a product through its entire life cycle. So we start the extraction processing of raw materials, manufacturing costs, distribution, use, recycling, and final disposal. So the entire lifetime of a product here needs to be assessed in order to come up with a useful assessment of these footprints. Yeah, so this life cycle analysis, of course, involves all the energy and material that is required across the value chain of the product. And so the assessment is done as a cumulative assessment of all the potential environmental impact. There are also standards for this. So ISO released the standards 14040 and 14044 standard suite for this describing these life cycle analysis processes. Okay, so there are two examples for an illustration for this life cycle. So we start with the raw material, we manufacture that, we package the product, we distribute it, then we use it, and then finally we dispose it. Another way to show that, because of course you might ask, okay, how do we transport stuff from manufacturing to packaging? So here we see the transportation among all the stages here. So it's a bit different. So we start with the resources, manufacturing, storage, retail, then use and recycling here. Yeah, so if you think about the social media applications we want to look at, we have this large number of devices being involved. Yeah, so starting from servers to network infrastructure, switches, hubs, whatever, then the consumer devices. So doing a life cycle analysis, yeah, for all these devices is obviously difficult. Yeah? So that's not a task which is kind of trivial. So that's really challenging to do. And the question is then how exactly we do that. But at first, I'll give some example from a rather recent publication here entitled "The Overlooked Environmental Footprint of Increasing Internet Use." And here, this is one of the studies which is an exception because this does not look only at the carbon footprint, but also looks at the impact of using stuff in different countries here. So as an example, we see here the carbon footprint caused by gigabyte of internet use. Yeah? So corresponding to data. And what is shown here is CO2 in grams per gigabyte. And what we see here, for example, is that the carbon footprint has a median here, but there is a huge variation worldwide. So there are huge differences here. Also for the water footprint, you see here that the median is down there, also a huge variation, and the same is true for the land footprint, where the median is here, and we have variations to minimum and maximum, quite a lot. So where does this come from? And it comes from basically in which country you do the deployment and use devices, for example, and where you consume the gigabytes of the internet. And then so here we see the deviation of these environmental footprints. So red is the carbon one, blue the water, and green the land footprint of a unit of electricity used for data processing and transmission. So here interesting, we restrict to electricity usage here. So it's you see a rather narrow focus that is looked at. So for example, the product, the raw material is not considered here that is used for the production of devices. And the interesting thing is here, these variations are based on the country's energy mix. And so once we look at these differences here, it gets clear that we have a large variation in energy production technologies and efficiency around the world, and this has an enormous impact on the environmental footprints here. Yeah, for example, if we look at Brazil, yeah, in Brazil we are rather below the median here. If we look at the carbon footprint, on the other hand, we have a large plus in terms of water and land footprint. So what's the reason for that? Looking into the energy mix of Brazil, it's clear that Brazil uses a lot of hydro energy and does not burn a lot of fossil material for producing its energy. So here we see that the carbon footprint is rather low, but on the other hand, this has to paid with something. So we have a higher water footprint and land footprint here. As I already said, interesting again here is France. Yeah, so in France, we are below the median for all the footprints, and there was no information given how this was calculated concerning the atomic plants, because probably end storage for atomic waste has not been considered, because this would have a rather high impact here on the land footprint probably. Other countries like Germany are interesting, so we have a rather high land footprint. I would assume that this is due to the daylight mining of coal in Germany, because this consumes very large areas, and so probably this is the explanation for that. But I'm not sure on that. So this is just speculation. And this can be looked at for different countries, and I find it really interesting to see that the country where you use media technology, basically, or where you consume data from the internet, has a tremendous impact on how you impact the environment. So which footprint is more severe. For example, here if we look at the hydro energy, we have a huge consumption here, but the water is not destroyed. So it's used for producing the energy, but it's not gone. And so this footprint here is probably not that severe, as long as it's not a gray footprint. So that would need to be assessed if this is gray or not. Okay, so this is an important lesson to learn. So depending on which country we are, we see big differences in the different footprints. Okay, and here is something important also for take home here. We can change application settings, and we see an impact on the carbon and the water and the land footprint here. So for example, so originally we look at streaming applications or video streaming application, and we can compute with figures for the footprints. And then if we reduce, so this is in HD resolution, if we reduce the resolution to SD, and we see an enormous impact here on the footprint. So this is factor of almost 10 reduction here for the carbon footprint, land footprint also significantly, and water footprint as well. So this very simple strategy already reduces the footprint quite significantly. So here this is an example and visualization of this, so how strongly we do this. The second example is here looking at video conferencing, and this is why I switched off my video here. So once we have the video on, Yeah, and so we see the carbon footprint per hour. And once we switch the video off, yeah, this is an enormous difference here. So by simply switching video off, we have a tremendous effect here. Minus 96% reduction here of the footprint using this very simple measure. In numbers, I give just 2 examples here. So first example, a common streaming service has 7 gigabyte per hour of streaming in high video quality. And this has a carbon footprint of 441 CO2 emitted per hour. If we assume streaming 4 hours a day, this results in a monthly carbon footprint of 53 kilograms. However, if we lower the video quality from HD to standard definition, then the monthly footprint would drop to 2.5 kilograms CO2 emitted. And this saves the emissions for driving a car from Baltimore to Philadelphia. So this is a US paper, so 150 kilometers. For a single subscriber, if 70 million streaming subscribers would do so, we see a monthly reduction of 3.5 million tons of CO2 emitted, which is the equivalent of eliminating 1.7 million tons of coal, or 6% of the total monthly US coal use. So this is enormous, right? So just reducing from HD to SD. Second example with the video conferencing, similarly, so standard video conferencing service uses 2.5 gigabyte per hour and has a corresponding carbon footprint of 157 grams. If we assume 15 1-hour meetings a week, their monthly carbon footprint is about 9.4 kilogram. And if we turn off the video, we reduce the monthly emissions to 377 gram. Yeah, so enormously. And again, comparing these to other usage scenarios, this would save the emissions of charging a smartphone each night for over 3 years. And if we look at 1 million video conference users would make the change, this would reduce the emissions by 9,023 tons of CO2 in 1 month, equivalent of the emissions powering a town of 36,000 people for 1 month via coal. So we see this simple change of setting has a significant impact here on this footprint. So this is kind of impressive. Okay, when looking into this topic, I looked into the history a bit of comparing different media. First papers found is on news consumption. So looking at news consumption here, and there are basically two directions I was able to identify. So comparing the consumption of newspaper in printed form versus tablet-based e-paper reading, or the second topic, comparing the consumption of news via newspaper, online newspaper, and broadcast television. And I will look at the second case in a bit more detail. You always see the corresponding publications here given in footnotes. So this is work from 2003 I will be talking about, and the first one is from 2010. Okay, what is important when assessing these footprints is the definition of the system boundary, which means that which parts of the entire chain are we looking at? So preferably the entire product chain should be considered. It's not always possible and not always useful. So for example, in this news delivery study, the cost of journalism has been ruled out. Also because the assumption is it's the same for the different types of media. And also recycling of electronic waste is not considered. Yes, so for these devices, we only look for disposal, but we do not look into recycling here. But for paper, we look at the recycling path here. Okay, so here this work is so old that it's the unit that has been considered is not CO2 equivalent emissions, but it's based on eco points. So this measure emphasizes energy consumptions, but also air emissions, some emissions to water and land are also evaluated. So this was basically used in Switzerland a lot, and this work originally it's from Switzerland. Okay, so if we want to do that, we have a highly complex system that has to be modeled. And as it is with most of the work that is seen in this area, the majority of modeling is taken from various existing sources, like papers or statistics and things like that. So as in this case, lifetime and energy consumption of devices, disposal and recycling of newspapers, disposal of electronic waste, manufacturing the newspapers, manufacturing the devices, and all this stuff is taken from other sources. In this study, only the user behavior is modeled when consuming the news. And also the length of a typical news item is also measured and determined. But the rest of the material is taken from sources, and then the modeling is done. And here, these are results of this study when we consider one news item only. And here we look at the life cycle stages. So we look at the production, and here we have those delivery parts, which also obviously consume only a small number of eco points. And then we have the use here. So this is watching a news item on television. This is for news item in internet newspapers or online news, for example, where we have the production of the PC here. We have the use here, bit more on disposal here. And then this is interesting. So we have the printed newspaper, but only one news item. And the idea is here to take only a fraction of the values of the entire newspaper to account for the fact that we look at a single news item. And here the result is kind of surprising, but not really if you think that a single news item is very small in a newspaper. So here, this consumes, the printed newspaper consumes the lowest amount of eco points. The most expensive one is internet reading, and television news is here in between. So the bars to the right, but we have a potential variance of the new items here in terms of size, for example, and also user variability, and this takes these variances into account. Now, when looking at the entire newspaper, then the situation changes drastically here. So here is the new Zürich Zeitung, which is analyzed. This is Blick, which is similar to Kronenzeitung, I think. Then we again have the internet reading of the newspapers, online reading, and the daily news on TV. And here we have the typical result that you would expect, basically, that here the production of the newspaper dominates the cost for real newspaper reading. Also the transportation here is significant because the new Zürich Zeitung is pretty thick, so the transport is expensive. And also the distribution, so for the local distribution and also disposal, get some costs here. In this evaluation, we have some credit here, and this credit is the energy that is recovered from burning part of the waste paper. So this is so to say good, because we get some energy from that, for example, heating. Recall that this TV stuff here is broadcast, so terrestrial or satellite broadcast. If you watch TV via internet, the situation changes, of course. But for this traditional broadcast TV, the costs are seen to be lowest here in this comparison. Yeah, there are some results also that you could look at. So the production phase of the newspaper here, you see that the paper production here dominates, and the rest is like less than a quarter. If we look at online reading here, so the echo points that are spent for the operation of the telephone network and data transfer by a router dominates here. And we see already here, okay, at that time that was inefficient network technology that is used. So nowadays, this evaluation would look differently because here the share of the transmission costs would be lower. Okay, again, looking at the energy mix. So this is on this right-hand side. This is interesting also, because what we see here is if we replace the Swiss energy mix by an average European mix here, the situation changes here. Because in this case, we have much higher costs of electricity, and then the relation among the different variants changes again. So here, for example, the internet newspaper under the conditions discussed gets more costly than at least the real newspaper Blick. So this energy mix is important. And of course here we see the time dependence, which is not given for the real newspaper, but of course for TV usage and internet usage, the costs in terms of echo points increase. Okay, coming more to the nowadays, second historical work from 2014, looking at the comparison of streaming versus DVD. So DVD is meant as DVD and Blu-rays. And this 2014 study also did a life cycle assessment to estimate primary energy use and greenhouse gas emissions. So it's again the carbon footprint that is looked at here. So 4 different types of DVD methods have been considered, and online video streaming. So this discussion is a very prototype one. So we assess the effects of dematerialization, because we replace physical goods or activities with equivalent services provided through the internet. So streaming of music and video entertainment are prominent examples, or using teleconferencing to reduce business travel and online dating, for example. Okay, so streaming video is clear. So we look at streaming in the type of full-length movies here in this work. And for DVD Blu-ray usage scenarios, we look at 4 different ones, which are real scenarios here, like the mail rented scenarios, which has been done by Netflix also. So look where Netflix came from a DVD rental agency. And this was done as a mail service subscriptions, where the DVDs are mailed directly to the customer from centralized warehouses. I think this service was stopped just some years back, so it was in existence until recently, actually. Store rented is very different, where the consumer travels a short distance to pick up and return then the rental disc. So typically in the US, driving with a big car. Then we have mail purchased DVDs, where you just buy DVDs via Amazon, and store purchased is where you buy DVDs from a store, so where you go there again by car. So what do we have to consider here? You can see here that the different parts that need to be modeled and assessed for this for assessing the carbon footprint here. So we have to look at manufacturing the DVD. Look at the shipping then. Then we look at the warehouse here. So the retail case that is used for that, and the rental paper sleeve. Then delivery, either postal or personal service. Playback with different devices here. And viewing also with different devices. So a lot of things to consider here. In streaming video consumption, it's like looking at the data center building, the networks, access networks, ADSL or cable, then router or cable box, playback, again, different variants, viewing with different variants. So just showing for this particular example the things that we need to consider here. Okay, these are the results of the study, and this is kind of also you would expect if you think about it, but it's very clear. So the variants, the DVD variants, where you go to the store and purchase the DVD is, well, second worst. The worst one is if you go to the store and rent. Why? Simply because this DVD transport by the customer is done twice. So you get it and you bring it back with your car. So that's this part here. While mail purchased, mail rented, and streaming has the same amount of kilogram of CO2 equivalent here per viewing hour. Of course, this has to be seen as at that point of time with the technology at that point of time. So these evaluations and assessments change with time, with energy efficiency of the devices, and so on. Here is a look into more details, which can cause higher or lower footprints. So example, the data transfer rate that we see in the streaming application is of course impacting here, because if we have a higher data transfer rate, we have seen this example with the high resolution, then we increase the footprint considerably. For the other scenario, like store rented, we have to look at the travel distance of the customer. We have to look at the fuel efficiency of the vehicle, for example. So there are many components that are important and play a role, and they have impact on the footprint that we have. We have seen that the transport of the DVD by the customer is very important. So this customer travel distance, the vehicle of the customer and its efficiency play an important role in the assessment here. Okay, there are some politics here. If we look at the ICT carbon footprint calculations. So the numbers are large. So the electricity consumed by ICT on a global scale is 1.4 to 3.8% of global greenhouse gas emissions. That's a lot if you compare that to airline industry. It dominates this number. And about 1/3 of that, so roughly 1% of global greenhouse gas emissions is probably streaming video. So video on demand, YouTube, porn, live streaming, and so on. With the pandemic, we saw an increase by 40% of that. And also something which I did not know, despite, so this increase was seen despite that both companies, so YouTube and Netflix, as well as PlayStations, they reduced the resolution to cope with the demand at that time. So that's interesting, and even though we've seen an increase by 40%. ICT will constitute about 15% of global electricity consumption by 2040. This is one assumption here. So these are large figures, and this illustrates why different stakeholders, well, they do follow different political interests when it comes to studies concerning these footprints. So this is not only about science, this is also about politics, and this has to be kept in mind when we look at papers, and it's always interesting to look at the affiliation of the authors. Okay, so there is work on surveying methods for determining ICT carbon footprints, also for streaming videos. So there are 9 that have been compared in one study, and it's clear that there are difficulties. Right? Like I mentioned, how to define the system boundary. This is diversely done in literature. Concerning all the infrastructure like data centers, networks, devices, should also the embodied energy, so the energy that was involved in manufacture, be considered. This is an important question, because in mobile phones, we see that 90% of the electricity consumption occurs before these devices reach the customer, so in production. What about the pollution and mining and disposal? So this looks at these land footprints and water footprints, for example. And also we see very different methods in data collection system modeling. And as a consequence, if we look in literature, we see a large disparity among result figures. And looking closely, we really see cherry picking here in papers when it comes to modeling resource consumption and prediction results. So this is really interesting to see. And 2 quotes from a recent paper on this. We quickly realized that much of the literature on the subject used figures from previous documents, very often without cross-referencing them with others and without taking precautions regarding the limits of the validity. And as we researched more deeply, these issues turned out to reflect not only the regular turnover of scientific findings, but also ideological agendas. We began to identify alliances, rifts, and tribes among the engineers studying this topic. And there is an interesting case shown in literature where the so-called SHIFT project, an important project assessing the footprints of internet use, basically, versus the International Energy Agency. So due to time, I don't go into detail with that, but I've given the links here, and you can look at this. And it's interesting because the International Energy Agency really was very, very picky about the work by the SHIFT project, because in the SHIFT project, large numbers have been shown. And so they did some unfair play when discussing their results. And of course, you can raise the question, why does it need so the International Energy Agency to reassure the public that the energy consumption of streaming media is not a concern? Yeah, of course. Yeah, it's the Energy Association here, and they basically act in the interest of the electricity and industry. So this is one example. So you can look up this example here in the slides, where it shows what the IEA did with the data of the SHIFT project. So they exaggerated their results, so they became really ridiculous, basically. Okay, so finally, comparing social media. And this, we have seen that, so it's difficult. Yeah? So modeling this entire environment here is a very different task. And this explains also why we do not see much literature on that. Yeah? So we have two results here. On the left-hand side, so looking at the CO2 generated in 60 seconds of social media usage on the left-hand side. And so this is from a web page here. On the right-hand side, usage 1 hour is published in the sustainability journal here, and considering 4 different ways how to measure that. And what we see here is, yes, TikTok here is leading in both studies. Yeah, so on this side, Netflix does not really count as a social media, right? So it's video streaming basically, so that does not count here. And then for the others, it's a bit difficult to compare. So I produced this comparison here. So looking at hourly use and the result in grams CO2 equivalents here, comparing YouTube, Facebook, and TikTok. And what we see here is that the results do not correspond well. So these are the range of the 4 methods that have been investigated here. This is from the website here, and we see that this result is clearly out of the range here. So it's too low. For Facebook, it's too high. It's also out of the range. Only TikTok here, well, this is close to the left boundary of that. If you look at this sustainability paper, it's published by MDPI, so this is a very problematic publisher here. The paper is extremely confused. So here is the reference. The title is promising here, but if you look at their methodologies, you see that this is not really very reliable. So this is a problem here, that we see really poor quality papers in this field. Partially, this can be explained because it's really difficult to do that modeling, but partially, I think, yeah, people just, well, they find the topic cool and maybe want to publish on that, but do not really solid work here. So that's difficult really to get reliable answers on these questions here. So looking at this, the left-hand side results, so based on green spectre, and also here I provided then a link where you can determine your own social media footprint from this source, and they also explain how they do this. So this looks rather well from my perspective. So what's the carbon impact for a average mobile social media user on a mobile phone? So it's 160 gram equivalent per day per user. So this is like driving 1.4 kilometers by a light vehicle. And if we look at the year assessment here, we get 60 kilogram of this, which is equivalent to 530 kilometers traveled by a light vehicle here. So this is something, but not completely crazy. We see that we have an impact, and we have seen that with some methodologies we can decrease this footprint. One example, which I find particularly bad here in this context, is also from this sustainability paper I mentioned, where really I think giving such an example does not really help and is really stupid. So here the first chart compares, here's only well, the footprint of using 1 hour. So just streaming here by a smartphone, weighted average over several devices, and boiling a kettle. Okay, we see, okay, this is kind of, if we use it for 1 hour, this is comparable to boiling with a kettle 1 liter of water. Okay, that sounds okay. The second comparison is a disaster. It compares the use of 1 day, yeah, so streaming for 1 day, and compared this to the carbon footprint of a return flight Paris-New York. And here are the figures, yeah, that we see for the streaming, and the flight is shown as this, with a very low number, with a ridiculously low number. In fact, I've checked, the return flight Paris to New York is about 1,900 kilograms of CO2 emissions. So far more, of course, than this daily use of streaming. So I value these investigations very much, but if you give incorrect examples like this one, you really do no good. Yeah? And so this really, I think that really negatively impacts the research and all the knowledge that has been acquired over time. Because if you present this example to somebody, everybody would say, okay, this is ridiculous. What have they done? Yeah. Yeah, and it also sheds light on this publisher. So this publisher is well known for its low quality journals also, and this is another example for a paper that has some real ridiculous content here. Okay, to conclude, the observations that I did when looking into this is the literature on the topic is scarce. So you do not find a lot of studies, and many studies are of low quality, which you already see when they describe the methodology. And one of the reasons for that is simply that the modeling of the entire systems requires enormous background knowledge, or you trust external resources, which is always difficult because you often do not know which sources are really reliable. So that's difficult. And if you look at papers, several papers exhibit obvious shortcomings and mistakes. So this gets very clear when looking into those. And in addition to that, people and organizations involved in these topics, they often have some political, economical, or ecological agenda. So this is not pure research without any application context or so. So this is highly political. So this combination with low quality papers and this political interest here is a problematic combination here. In any case, what we have seen, and I tried to pick examples from rather reliable papers here, that results often reveal surprisingly high ecological footprints, and also easy way to reduce those. So I was not aware of, I didn't think about it, that changing the resolution of, for example, of streaming media like Netflix has such a high impact. And when looking on the mobile, it doesn't really make a big difference. So it's an easy task to just save some resources here. So my conclusion is that solid and especially reproducible research in this field is required, because it's very useful to raise the awareness that social media consumption does have a non-negligible ecological footprint here, and that also changing individual settings can make a large difference. Okay, that's what I wanted to say. Thanks for your attention, and I'm of course open to questions.
Thank you very much, Andreas. It's similar to what my experience from last week. I think this is almost like a crime, watching as a crime story, what you have explained. And especially looking at your last slide, you say, in fact, to a certain extent, also we have it in our hands to change something. albeit it's difficult. Now, as I have already said at the beginning, I had really problems with my connection, but perhaps I had to store some CO2 emission. I don't know. I'm now with my mobile online. And if there are questions in the chat, I would just like to ask you to take the questions from the chat.
Okay, let me see if I see the chat. Okay, that's
so far I see
regarding the footprint median.
Yeah.
How expensive is a gigabyte in Austria? Okay, yeah, Austria has a relatively high share of hydro energy. So compared to other countries, so it's definitely better than like you looking at the UK or like Australia or so. Yeah. So Austria is kind of comparatively better than other countries. Just from the energy aspect here. Of course, as I said, you have to look into other things here. So we have to consider the network infrastructure. So which networks are being used? How much energy do they consume? So how old are they? So when do they have to be replaced? So as I said, if you start thinking about it, there are so many components that have to be assessed. Yeah, so difficult. Okay, which sources would you consider reliable for comparison or research regarding CO2 footprint? Yeah. So determine if, I mean, for electric cars, there is much more literature. So I've looked just because I'm interested in that, into literature. So there is so the publications on cars are much more also reliable, I think. Yeah. It's one thing is that once the car is produced, it's basically on its own. It's not connected to the network and the data flow, so it's a bit easier to analyze during the usage. Production is a different story, and especially with electric cars, the disposal and so waste disposal with respect to batteries is an unsolved problem. So we will see this huge problem coming towards us, and this is extremely difficult to model because it depends on really the type of car that you drive, because the battery technologies are so different. So which sources I would consider reliable? So there are many statistical collections about data usage and things produced, and I don't think they don't have a political background, and I think you can use those. They seem to be reliable. And as soon as you look into papers, you really have to look into the methodology section, because here huge differences turn up. So some papers really use other stuff unreflected. They do not really contribute. They just add the figures that they find in other papers without questioning them. But some papers, like this paper I used at the start with the different footprints, they do really sophisticated modeling. And I think the more you think, the better it gets, and you see that authors really wanted to contribute something and not just produce a cheap paper like the example at the end I brought with the comparing social media stuff. Yeah. So these official statistics, I think that's a good source. Yeah. But yeah, it's a difficult story. I mean, especially in cars, it's an extremely political discussion. So if we think about cars, so for me the big question is, so why are hydrogen-driven cars, which directly burn hydrogen, why did nobody look into that with more sophistication? And the simple answer is because there was no lobby. So the electric industry, they are interested in selling electric cars. They are not interested at all in hydrogen cars. So this technology has only been researched in Japan, and they have some cars like that. But this is not objective, right? So this happened because there is a huge interest here, and I mean, it's extreme with cars, but to some extent we also see this in ICT. So it's not free of values and opinions and political agendas. So that we have to be aware of that.
I want to, it fits to your last comment here, not? When you were putting up this first example that turning down the high definition to standard definition can save, I think we said 6% of the coal usage.
Yeah.
And I thought, why don't forbid high density at all? Huh?
Yeah.
I know this is a difficult question, but this is really unbelievable to a certain extent how easy it would be to save energy.
Yes, it is. It is, in fact. But I would pose the question, why don't we forbid SUVs driving around in cities? That's more obvious, I think.
I totally agree, but I think this is not part of this lecture.
Well, it's all connected, right?
It's all connected, yeah. But perhaps a little bit on a more serious level, although this is serious as SUV, turning off the video. I totally agree with you that when you say, wow, it's so easy to turn off the video and save energy. But for example, for this lecture now, of course, I also turned off my video since you have done it also. But isn't this also a bit, I would say, boring or kind of very, very
depressing. I find it depressing if I just talk to the screen and nobody's there.
You don't know, is there anybody out there, or are they just all sleeping or answering their emails? So I think there is also a collateral kind of problem here, and this you also have to decide or to discuss in our kind of communities and our settings, and then decide what to do about it.
Yeah, definitely. I would suggest an in-between solution, actually. So my suggestion in this case would be that only speakers are automatically visible, and the others, for the others, the video is turned off. So that you do not have all the videos there, but it's important to see a person speak. Then this would be kind of a compromise, so that you don't have, I don't know, like here in this lecture, I don't know how many participants we have, 119. So if we don't have 119 videos running, but we only have the videos running of active participants. So if somebody poses a question or for the speaker or during a discussion. So this would be a compromise and still saving a lot of energy.
Yeah.
And also the question here from the chat, so data saving mode, I don't really know what you mean by that. So if it means reducing the data, of course, yes, that reduces CO2, because the load on the network is lower. Yeah, of course, and that's something that needs to be considered. There are discussions about that, because some people say, well, networks and data centers, they do run anyway, no matter how much data is transferred. But, well, this impacts on the planning. If we reduce the data that is transferred and that is processed in data centers, in the long run, we will need networks of lower capacities and data centers with lower capacity, and that reduces, of course, the CO2 emissions definitely. So that's something like the argument, okay, I'm not flying, but the plane is still in the sky. This is true for one person, but if it's for several persons on the long run, then several flights will be canceled because they're not economic anymore. And so this is kind of similar with networks and data centers. So on the long run, it will help. Of course, it's true that at the immediate perspective, you might not gain a lot. But so that's more for your end device. So if you have a high resolution decoding of a video or a standard definition decoding, that makes a tremendous difference in energy consumption. That's clear. For the data transfer, it's a bit more tricky, but still there is an argument why it makes sense.
So I think we have still a long way to go until we all have also the awareness and the immediate understanding what is necessary and what is just nice to have, and what we should turn off the one way or the other. since we said until something like 6 p.m., we are now 4 minutes after 6 p.m. Andreas, I really want to thank you for your presentation. As I said, this is really almost too exciting, but it is also a call for action. And this is the whole reason for this public lecture series, that we are aware that there is something to do and that we have it to a certain extent in our hands and that we have to teach our students in this direction. Thank you very much.
True.
If okay for you, it would be great if you send me the slides, so we will put them also online, just to have the slides online and not only the video. And yeah, we see each other next Monday, and have a nice evening with low energy consumption.
Yes, thank you very much. It was my pleasure to contribute to this
Thank
series.
you, Andreas. And thank you to the participants. Goodbye.
Have a nice evening. Bye-bye.